Very good morning. So let's start with the explanation of the chapter Combustion and Flame, which we were already doing in the last class. So in the last class we have studied how air is necessary for combustion. Okay, so how oxygen is very important. Without oxygen there will not be any kind of combustion. So we have studied all these. So now let's move on to the next topic, that is how can we control fire. So you must have seen or heard about the fire breaking out in homes, shops and factories. Does your city or town have a fire brigade station? Yes, isn't it? Our city or our town definitely has a fire brigade station. So you must have seen in the picture how this is done, how the fire is extinguished. Okay. So whenever a fire brigade arrives, what does it do? The first thing, what does it do? It pours water on the fire. Water cools the combustible material so that its temperature is brought below the ignition temperature. So whenever there is a fire brigade arriving, what will it do? Firstly, it will pour water over the fire. So whenever water is poured above the fire, what happens? Water cools the combustible material. Whatever is burning, the temperature will be cooled by the water. Whenever you pour the water, the temperature of the combustible material or the fuel which is burning, that will be brought below the ignition temperature. So whenever the temperature is below ignition temperature, you know a substance cannot burn. Okay, so the fire will stop from spreading. It will prevent the fire from spreading. Water vapors also surround the combustible material, helping in the cutting off the supply of air, so the fire is extinguished. So the water vapors, there will be vapors around the combustible material. You must have seen fumes coming out, isn't it? So those are water vapors. So there will be vapors around the combustible material, and whenever there are water vapors around the combustible material, it helps in cutting off the supply of air. So the supply of air is cut off. So whenever the supply of air is cut off, the fire is extinguished. Okay, so you have learned that there are three essential requirements for producing fire. These are fuel, okay, so that means the substance which burns, that is the fuel, very important. Okay, air to supply oxygen, and heat to raise the temperature of the fuel beyond the ignition temperature. So there are three things. Firstly, fuel, that means something that will burn, that is the fuel. Air means oxygen, so oxygen is needed for burning. Thirdly, heat is also needed to raise the temperature of the fuel. Okay, so fire can be controlled by removing one or more of these requirements. That means if you remove the fuel, will it burn? No, because fuel is only burning. If there is no fuel, what will burn? Now air, if you remove, then also there will be no burning. Without oxygen, combustion is not possible. Okay, so the job of a fire extinguisher is to cut off the supply of air. So what does the fire extinguisher do? It basically cuts off the supply of air, or it brings down the temperature of the fuel beyond the ignition temperature. Okay, so what is the most common fire extinguisher? All of us know it is water. Okay, so whenever something is catching fire, first thing you do is you pour water. But water works only when things like wood and paper are on fire. So whenever a paper is burning, you pour water, it will stop burning. Wood is burning, you pour water, it will stop burning. Okay, but if electrical equipment is on fire, if you pour water, what will happen? You yourself will get electrocuted, because you know water is a conductor of electricity. Water conducts electricity. So whenever you pour water over electrical equipment, there may be short circuit or you may be electrocuted. Okay, you have to be very careful. So water is not suitable for fires involving oil and petrol also. Do you recall that water is heavier than oil, so it sinks below the oil and oil keeps burning on the top. So if there is oil and petrol, and you are, the oil and petrol is burning and you are pouring water over it, you think that you are going to control it. Nothing is going to happen, because density of oil is less than water. Oil floats on water, isn't it? So whenever you pour water, the water will sink below the oil. It will not control the fire. Okay, so for fires involving inflammable materials like petrol or electrical equipment, okay, that means petrol, inflammable material means something which catches fire easily. That means the ignition temperature is much below much lower. Okay, those are called inflammable materials like petrol, diesel. Okay, so best extinguisher. Okay, carbon dioxide is the best fire extinguisher because carbon dioxide, being heavier than oxygen, covers the fire like a blanket. So carbon dioxide is quite heavy than oxygen. It is heavier, so it will cover the fire like a blanket, and the contact between the fuel and oxygen is cut off. So between fuel and between oxygen there is carbon dioxide. So carbon dioxide is not allowing the oxygen to come closer to the fuel. So will the fuel burn? No, it will not burn. So the added advantage of CO2 is that it does not harm the electrical equipment. Okay, whenever the electrical equipment is there, best fire extinguisher is carbon dioxide because first thing, it will control the fire. Secondly, it will not harm the electrical equipment. Okay. Now, how do we get the supply of carbon dioxide? It must be stored at high pressure as liquid in cylinders. Okay, in what form is LPG stored in cylinders? So you know how liquefied petroleum gas is stored in cylinders. So similarly, carbon dioxide also has to be stored in cylinders. And you must have seen carbon dioxide extinguishers, fire extinguishers. Have you seen CO2 cylinders? It is there in your school also. Okay, and in offices and everywhere it is there actually. So when released from the cylinder, CO2 expands enormously in volume and cools down. Okay, so it will be released in the form of a spray from the cylinder, carbon dioxide. Okay, so it will expand in volume. That means it will be, sprayed. It will be like a spray. So spray, it covers a huge area, isn't it? So it will expand in volume and it will cool down. So it not only forms a blanket around the fire, it also brings down the temperature of the fuel. So it will also bring down the temperature of the fuel. So that is why it is an excellent fire extinguisher. Okay, so question can come, why CO2 is an excellent fire extinguisher? Okay, so another way to get CO2 is to release a lot of dry powder of chemicals like sodium bicarbonate. Baking soda, all of you know, last year you had studied, isn't it? Or potassium bicarbonate. Near the fire, these chemicals give off carbon dioxide. Okay, so sodium bicarbonate or potassium bicarbonate can also be used. Okay, if you release a lot of dry powder, so these are the dry powders. So if you release a lot of dry powder, then near the fire, that also gives off carbon dioxide. So in that way also you can get carbon dioxide. Okay, so now we come to the types of combustion. So bring a burning matchstick or a gas lighter near a gas stove in the kitchen. Thus, turn on the knob of the gas stove. What do you observe? Okay, so you bring a burning matchstick. So all of you know matchstick. Okay, so bring a burning matchstick or a gas lighter near the gas stove. What will happen? When you turn on the knob of the gas stove, immediately the gas will start burning, isn't it? So we find that the gas burns rapidly and produces heat and light. Such type of combustion is called rapid combustion. Okay, rapid combustion means the combustion in which the substance burns rapidly or substance burns very fast. So that is called rapid combustion. So so this happens in the case of gas lighter. Okay, so whenever you bring a matchstick or a gas lighter near the gas stove, what happens is it burns suddenly. Okay, it burns rapidly. So that is called rapid combustion. Okay, so there are substances like phosphorus which burns in air. Okay, at room temperature, the type of combustion in which a material suddenly bursts into flames without the application of any cause, spontaneous combustion. So when you take a piece of sodium, okay, and you just keep it in the open, at room temperature it will start burning. So you haven't done anything, you have just kept a piece of sodium in the open, it will start burning. That is called spontaneous combustion. Phosphorus also, you just keep little bit of phosphorus at room temperature in a table, it will start burning on its own, you have not done anything. So that is called spontaneous combustion. Spontaneous combustion of coal dust has resulted in many disastrous fires in the coal mines. Spontaneous forest fires are sometimes due to the heat of the sun or due to lightning strikes. So in case of forest also, you will find there is spontaneous combustion. So whenever there is the heat of the sun or there is lightning, suddenly the forest will catch fire. That is called spontaneous combustion. Okay, so we'll continue with the explanation in the next video. Thank you.